Hey guys, welcome to Datasie. In this series of videos, we're going to go over the concept of limits starting from the basics. In this particular video, we'll start by introducing what limits are and explaining their informal definition. So, what's a limit? Imagine you have functions, f of x, that's defined around a particular point like a. Maybe even that functions including that point or not. If you represent the functions graphically, you might see that if the function doesn't include a, there will be an open circle at that point, like this figure. If it does include a, there will be a solid circle, like this. If you can pick up values of x really close to a, but not necessarily equal to a, for example, as x gets closer and closer from the left of a, the value of f of x approaches to L from below, and if we get closer and closer from the right of a, the value of f of x gets closer and closer to L from above. Then we say that as x gets closer and closer to a, the function's f gets closer and closer to the limit L. This explanation is called informal definition of limit, because terms like sufficiently close and as close as we want are a bit fuzzy and not super precise. For now, consider limits analytically. We have different methods for evaluating limits, but for this video, I'm going to focus on the direct substitution, which I will present in the form of a theorem. The theorem is about the limit of polynomials and rational functions. If you are dealing with polynomial functions, for example f of x, and a is a real number, then the limit of f of x as x approaches to a is simply the value of the polynomial at that point, which is denoted as p of a. Let's work on some examples. What's the limit of x squared minus 4 times x plus 1 as x approaches to 4? What's the value of this limit? What's the answer? So let's plug in 4 into these expressions. 4 squared minus 4 times 4 plus 1, which is 1. We're gonna get 1 and we get the answer. What about this problem? The limit of 3 times 1 minus x times 2 minus x as x approaches to 2. Like previous example, plug in 2 into the polynomial and we're gonna get 0. And for a second case, we have rational functions. If p of x and q of x are polynomials and a is a real number and q of a is not equal to 0, then the limit of the ratio of p of x over q of x as x approaches to a is equal to the ratio of p of a over q of a. Let's look at the examples of limits of rational functions. What's the limit of x plus 3 over x plus 6 as x approaches to 3? What's the answer? Another time, plug in 3 and we're gonna get 6 over 9, because 3 plus 3 over 3 plus 6 is equal to 6 over 9. And what's the limit of t squared over 4 minus t as t approaches negative 4? What's the answer to this limit? Another time, according to direct substitution, we plug in negative 4 and we're gonna get 2, because negative 4 squared over 4 minus minus 4 equals to 16 over 8, which is equal to 2. And the last example is about the limits of x plus 1 over x minus 5 as x approaches to 2. Now let's plug in 2 into the expressions. 2 plus 1 over 2 minus 5, and we're gonna get 3 over negative 2. That's it. We have 4 problems about direct substitution. And in the next video, we're going to work on these problems together. If you have any question, feel free to ask them in the comments. Thank you for watching, and make sure to subscribe to my channel for more tutorials.